Greetings, everyone. I've had to do this video, at least parts of this video, once already, so hopefully this one will actually come out. This is homework help for section 2.5. One of the questions was number 2. Can the graph of y equals f of x intersect a vertical asymptote, and can it intersect a horizontal asymptote? And then illustrate by sketching graphs. The second part of that question for the horizontal asymptote, we did go over that in class, and I had you guys graph in Desmos, or at least try to figure out if you can come up with a graph that intersects its horizontal asymptote, and then I told you one of our last examples did, and so you can go ahead and go look that up. As far as a vertical asymptote is concerned, most people would tell you no, but if you use a piecewise defined function, you can make this happen. I'm not sure if that's the intent of the question, but I'm not going to assume intent. I'm just going to go with, they just asked. Here's an example. 1 over x has a vertical asymptote at x equals 0. Now, if I define a second piece with the point 0, 2, and it could be any point with x coordinate 0, I just chose 0, 2, then that point is on the vertical asymptote, so it technically intersects the vertical asymptote. I don't think that's what they intended with the question, but again, I'm not worried about what they intended. I'm worried about what I can demonstrate based on how they asked the question, and this answers that question. Moving on to question number 8, same thing, we've got to sketch a graph. So again, you should start to interpret. If you're really wanting to learn this stuff well, you should pause the video and try it yourself before listening to what I have to say about it. That way you can at least see how much growth you've had from, watching the previous example. Actually, let me put this into darker color for the axes. So let's start interpreting here. The limit as x approaches 3 from the right goes off to negative infinity. So that means we have a vertical asymptote at 3. Remember, it just requires a one-sided limit going off to one of the infinities. From the left, it's going off to positive infinity, so we got it from both sides on this one. So from the left, positive infinity, whoops, choose a different color. And then from the right, negative infinity. And the limit as x approaches infinity is going to go off to infinity, so it's going to do this. And the function is odd. That's probably where a lot of people are getting stuck. Odd functions, if you can recall from pre-cal, have the relationship that, I'm going to put it in terms of symmetries because that's the way I prefer to say it, that they have rotational symmetry, 180-degree rotational symmetry about the origin. So in other words, whatever graph you sketch, if you were to pick it up and turn it over 180 degrees, rotating it about the origin, it should look exactly the same. So that's going to require a little bit of work on your part. But if you imagine picking this thing up and rotating it 180 degrees, this piece over here is going to have to point, whoops, let me get the blue over here. It's going to have to point down in this direction. Okay, 180 degrees, you're going to get a new asymptote, another asymptote, even though it wasn't mentioned. 1, 2, 3 over here at negative 3. And then you're going to fill in where these pieces go, and you're going to connect them with a nice function and make it all work. You guys can do it. You don't need my help for that. Now for number 19, we're taking a look at the limit as x approaches 3 from the right of the natural log of x squared, the quantity x squared minus 9. What I want to do first is I want to sketch the graph of the natural log function so you have it in mind. I know I always say tables and graph are the weakest method, and they are, but we're not going to exclusively use tables and graphs for this. I'm going to do some analysis here, but if you don't understand the behavior of the natural log function, then analyzing this is going to be a challenge. Okay, so the natural log function has a vertical asymptote at x equals 0. I hope you remember that, but if you didn't, there it is. It intersects the x-axis at 1, 0, so it's going to cross right here, and then it's going to asymptotically get closer to x equals 0 like this, and then it's going to bend off in this direction over here like this. All right, in case you ever forget how to draw that, remember what you should remember is that is the inverse of the exponential graph base e. And so if you plot the exponential graph base e and then you flip-flop the x and y coordinates, you can get the graph of the natural log function. All right, so we're going to do this in kind of two stages. We're going to need the natural log function and to understand its behavior, but not right away. That's the outer function here. If you imagine plugging in values for x, the first thing you'd have to do is square them, and then you'd subtract 9. So we have to do this calculation before we can take the natural log of whatever numbers we end up with. So x is getting closer to 3 from the right. Incidentally, the reason why it's getting closer to 3 from the right is because if we let x get closer to 3 from the left, then x squared, well, x would be less than 3, so x squared would be less than 9. Something less than 9 minus 9 would have to be a negative, and as you can see from the graph over here, the natural log function does not have negative inputs. So the domain is all positive numbers, and so if we plug in numbers less than 3, this would be negative, and we can't take the natural log of that negative number. So that's why we're approaching from the right. A little bit more into this. From the right means x is bigger than 3, which means that x squared is going to be bigger than 9. And so I'm going to have a positive result. But since x is getting closer and closer to 3, x squared will be getting closer and closer to 9. So this resultant here is all going to get closer and closer to 0 from positive numbers. Let me repeat that. As x approaches 3 from the right, x squared is getting closer to 9 from numbers larger than 9. And numbers larger than 9 minus 9 are still positive. So this whole thing is getting closer to 0 from positive numbers. So the reason why I want to think about that is I want to go take a look at the graph here. If the x values, or rather, the inputs into the natural log function, which over here are going to be the x values, are getting closer and closer to the closer to 0 from positive numbers, they're doing this. They're going in this direction here. Which means if we take a look at the outputs of this graph along that direction are going in this direction here. So the way I'm analyzing this, because I have this composition, this inner function and this outer function, I'm going to take a look at the behavior of the inner function as x is getting closer to 3 from the right. And then whatever that behavior is, I'm going to look at that trend in the natural log graph for its inputs. So since this is getting closer to 0 from positive numbers, I look along that trend here and look at the outputs and see what it's doing. It's going down that way. I will let you finish with what you're supposed to write for that instead of writing it for you. But you should understand what I'm saying, and I hope that gives you a better understanding. I will continue with more problems in the next video.